Hi, I am Lopamudra Sen. Welcome back to my channel Electronic Science Tutorial. You all know that I will start a new lecture series in NET question paper solution. In previous class, we will start some NET question paper solution based on the electrical conductivity concept. Today we will some numerical solve based on the concept of junction field effect transistor and MOSFET, that is the metal oxide semiconductor field effect transistor. Okay, so let's start our class. So what is the problem? The problem is, consider an n-channel depletion mode MOSFET having following parameters: VTN equal to minus 2.5 volt and Kn equal to 1.1 milliampere per volt square. If VGS equal to 0 volt and VDS equal to 0.5 volt, then what is the drain current? This problem is from UGC Net 2012 paper 3 June Electronic Science. So how we solve this problem? Here the given value is Kn, VGS, VDS and VTN. Okay, so first of all we see the options. Number 1 option is 9.96 milliampere. Number 2 is 6.43 milliampere. Number 3 option is 2.48 milliampere. And number 4 option is 5.56 milliampere. So how we solve this problem? Let us see. Here Kn value is given, that is equal to 1.1. From the basic concept of JFET, we all know that Kn equal to mu COX W divided by 2L. So what is the value of Kn prime? Kn prime is mu COX divided by L, right? So if the Kn value is 1.1 milliampere per volt square, then Kn prime is the 2.2 milliampere per volt square. Okay, so now VGS is 0 volt. If we evaluate VGS minus VTN, then what we get? That is 0 minus 2.5. So we get 2.5 volt, and that is VDS is less than this, because VDS value is 0.5 volt. So VDS is less than VGS minus VTN. When we get this condition, that is the drain source voltage is less than the VGS value minus VTN value, then we consider the linear region of the field effect transistor. So in this linear region, what is the ID current value? ID equal to, what we write? We write Kn prime, okay, third bracket, VGS minus VTN, okay, into VDS minus V square DS divided by 2, third bracket close. So this is the ID current or drain current in the linear region. So first of all we have to calculate the Kn prime value, which is equal to mu Cox W divided by L. Then we have to choose in which region we have to consider the drain current. There is VGS is equal to 0 volt, VTN is equal to minus 2.5 volt. So 0 minus minus 2.5, that is equal to 2.5 volt, and that is the greater than value, the VDS value. VDS value is given here, that is 0.5 volt. That is VDS is less than VGS minus VTN value. So JFET is in linear region, right? So linear region, when the JFET is in linear region, what is the drain current value? The drain current value is equal to Kn prime VGS minus VTN into VDS minus V square DS divided by 2. So if we put this value, we have to evaluate this problem. Okay. So here is the solution. First of all, we consider Kn, that is equal to 1.1, that is equal to mu Coxw divided by 2L. Then Kn prime equal to 2.2 milliampere per volt square, that is equal to mu Coxw divided by L. When we get Kn prime, then we have to decide that in which region we have to consider. We consider VGS minus VTN, that is equal to, that is greater than VDS. That means VDS is less than VGS minus VTN. That means the FET is in linear region. Now, what is the ID current in the linear region? That is Kn prime VGS minus VTN into VDS minus V square DS divided by 2. And if we calculate this value, if we put this value and then we calculate the value, what we get? That we get the drain current, that is equal to 2.48 milliampere, right? So the right option is 2.48 milliampere. Okay, I hope you understand this topic. Thank you. If you like my video, please like, share and subscribe my channel. Thank you.